Good morning, everyone. I am Kanimoli, Assistant Professor, Biomedical Engineering. Today I am going to present an important topic in the field of electronics, digital electronics and integrated circuits. First, we just learn what is signal. A signal is any information that changes with the time. Signals are classified into many types and most important signal is digital signals. This digital signal has only two levels. One is 0, another one is 1. For example, a TV remote sent digital pulses like zeros and ones to control the TV. Another one example, mobile phone signals. When we can talk on a mobile phone, our voice is converted into zeros and ones. This is a digital signal. Okay, let us start the digital electronics and integrated circuits. Now we know what is electronics. Electronics is a branch of science and engineering that deals with how electric current is used to control, process and transfer the information. Digital electronics is a branch of electronics and the electric current represented by 0 is low voltage and 1 is high voltage. It works with two values. This value is 0 and 1. These values are called as binary numbers. Digital electronics is the heart of the modern technology. Why do we use binary? Binary is simple, fast and reliable, and it reduces error and noise. Because of binary, computers and phones can work correctly even at high speed. Next, we have to study two important models in digital electronics. First one is combinational circuit. Another one is sequential circuit. So combinational circuit is this circuit has no memory unit. Then it result based on present input only. For example, adder, subtractor, multiplexer, demultiplexer, encoder, decoder, parity generator, checker, and magnitude comparator, etc. Then this combinational circuit is no memory unit. So the results are not stored in this system. To overcome these limitations, a sequencer circuit was developed. So what is sequencer circuit? It is a digital logic circuit. This result depends on the present and previous input, meaning it has memory. Example, flip-flops, counters and registers. Then sequencer circuits, it stores information and use flip-flop and latches as memory, and output changes based on clock signals. Sequential circuits build in flip-flops and combinational circuits build in logic gates. The common logic gates and are not XOR. Each gate has a truth table that shows its output for different inputs. Next, what are integrated circuits? I mean ICs. So an integrated circuit is a small chip. It made semiconductor material, usually silicon, that contain thousands or even millions of electronic components such as transistors, resistors, capacitors, diodes. And what is transistor and it used? The transistor, it is a small electronic device that can control the flow of current. It is a signal booster. Then resistor, it control the flow of electrical current. Capacitor, it stored the electrical charges. And finally diodes, it allows current to flow in only on direction. Next, why ICs are used? Why ICs are used? It is very small in size, low cost, high speed, reliable, low power consumption. So this IC is more than used in nowadays. Types of ICs: analog IC, digital ICs, then mixed ICs. Analog ICs means used in amplifiers, example operational amplifier, and then Digital ICs used in computers then and microprocessors. Example for 74XX series logic gates. Then mixed ICs handle both digital and analog signals. Examples: ADC. ADC means analog to digital converters. And IC families. More than IC families used in a chip. First one TTL. TTL means transistor logic. Next one CMOS, complementary metal oxide semiconductor. This CMOS family is most used in the electronics field because this chip is low power, high noise immunity, and then more used in widely used. Next one ECL. ECL means emitter coupled logic, then RTL resistor transistor logic, then finally DTL diode transistor logic. Real-time applications. So real-time applications used in digital clock and watches, calculators, washing machines, mobile phones, computers, then etc. Next, industry applications. Industry applications means healthcare industry, specific ECG and EEG machines, digital thermometers, blood pressure, then blood pressure monitors. Next, relations between digital electronics and ICs. So digital electronics use logic gates. Logic gates are built using transistor. So these gates and transistor are packed together into a small chip. So ICs are hardware foundation of modern digital electronics. Next one. Student skill development into ICs. So first one, logical thinking, circuit design skill, hardware implementation, programming mindset, and analytical skills, problem solving ability, understanding of modern technology, teamwork and project building. The hardware implementation or student skill development is used to logical thinking for students and learn to think step by step using logic gates, truth table, and Boolean algebras. This improves problem solving ability. And then another one, circuit design skill used in students become capable of designing simple and complex digital circuit and using ICs like 7400 and understanding sequential and combinational circuits. And program mindset means I think digital logic improves the foundation for programming microcontroller and embedded systems. Then analytical skills means students learn how to analyze then timing diagrams, flip-flop behaviors, and study the counter and registers operations. Finally, one example I have to explain one real-time application of a calculator. A real-time application of a calculator is performing quick